Welcome to Space Nexus. Please subscribe and hit the bell icon for more breaking updates. November 16, 2025. Humanity is electrified by a discovery from NASA's Perseverance rover on Mars. The rover has uncovered a potential biosignature, our strongest clue yet in the search for life beyond. This isn't just another rock, it's a possible message from a world that may have once been alive. The implications are staggering, challenging our understanding of biology and our place in the universe. The find, published in Nature, has passed rigorous scientific scrutiny and ignited global excitement. The specific minerals and organic molecules in a rock called Cheyava Falls are, on Earth, often left behind by microbes. Perseverance's discovery brings us closer than ever to answering the age-old question, are we alone? This discovery stands on the shoulders of decades of Mars exploration. The journey to Jezero crater is not just a story of one mission, but a testament to the relentless pursuit of knowledge that has spanned generations. Each chapter in this saga has been written by scientists, engineers, and dreamers who dared to imagine what secrets Mars might hold. Their collective efforts have paved the way for the breakthroughs we celebrate today. From the first flybys in the 1960s, when spacecraft captured the earliest close-up images of the Martian surface, to the historic Viking landers that touched down in the 1970s, each mission brought us closer to understanding the Red Planet. These early pioneers faced daunting challenges, from navigating the vastness of space to surviving the harsh Martian environment, yet their successes laid the foundation for everything that followed. The Spirit and Opportunity rovers, arriving decades later, were true trailblazers. They traversed the rugged Martian landscape, uncovering compelling evidence that water once flowed across the planet's surface. Their discoveries, ancient riverbeds, mineral deposits, and signs of past lakes, transformed our view of Mars from a barren wasteland to a world that may have once supported life. These findings ignited new questions and inspired a new generation of explorers. Curiosity, landing in 2012, marked another leap forward. With its advanced suite of scientific instruments, Curiosity drilled into Martian rocks and discovered complex organic molecules, as well as evidence of a long-lasting freshwater lake in Gale Crater. These discoveries suggested that Mars had the right conditions to support microbial life in its ancient past, fueling excitement and guiding the search for even more promising locations. The data Curiosity sent back to Earth helped scientists identify the most intriguing sites for future exploration. By mapping the Martian surface in unprecedented detail, researchers could pinpoint regions that held the greatest potential for revealing Mars's secrets. These insights were crucial in selecting the next landing sites, including the remarkable Jezero crater. Perseverance, launched in 2020, is the most advanced rover yet, designed to hunt for signs of ancient life. Built on the legacy of its predecessors, Perseverance carries new technologies and scientific tools, enabling it to explore Mars in ways never before possible. Its mission is not only to search for biosignatures, but also to prepare for the day when humans might set foot on the Red Planet. Equipped with cutting-edge instruments, Perseverance analyzes Martian geology and collects carefully selected rock and soil samples. These samples are being stored for a future mission that will return them to Earth, where scientists can study them in detail. This marks the first step toward bringing pieces of Mars home, a dream that once seemed impossible. Every mission has built toward this moment, culminating in Perseverance's historic arrival at Jezero crater. Here, in an ancient river delta, the rover searches for signs of life that may have existed billions of years ago. The excitement and anticipation among scientists is palpable, as each new discovery brings us closer to answering the age-old question, are we alone in the universe? The journey to Jezero crater is the story of human ingenuity and relentless curiosity. It is a testament to our desire to explore, to understand, and to push the boundaries of what is possible. As Perseverance continues its mission, we are reminded that every step on Mars is a step forward for all of humanity. Choosing Jezero crater was a calculated risk with high rewards. From orbit, Jezero revealed an ancient river delta, prime real estate for finding preserved signs of life. River deltas on Earth are hotspots for life and fossil preservation. The Bright Angel Formation, rich in clay and silt, offered the best chance to find biosignatures. Perseverance targeted Cheyava Falls, a rock at the edge of an ancient river channel. Jezero's diverse geology and history of persistent water made it the ideal landing site. The crater's layers are a time capsule, each one a chapter in Mars's story. Now that bold choice is yielding extraordinary results. The heart of this discovery is a single rock core, Sapphire Canyon, drilled from Chayava Falls. On-site analysis revealed a unique composition: organic carbon, sulfur, phosphorus, and oxidized iron. The minerals, vivianite and greigite, are often linked to biological processes on Earth. Their arrangement suggests a complex history of water and possible microbial activity. The convergence of organic molecules, mineral patterns, and sedimentary context makes this sample exceptional. It's not just one clue, but a tapestry of evidence pointing toward ancient habitability. Sapphire Canyon is the most compelling Martian sample yet. A biosignature is like a fingerprint left behind by life itself, a unique substance, structure, or pattern that, as far as we know, can only be created by living organisms. These can be chemical traces, physical formations, or even specific molecules that are strongly associated with biological activity. Scientists search for biosignatures in rocks, soils, and even in the atmosphere, hoping to find evidence that life once existed, or still exists, beyond Earth. The excitement comes from the possibility that these clues could answer one of humanity's oldest questions: are we alone in the universe? When NASA's Perseverance rover uncovers unusual patterns or chemical signatures in Martian rocks, it's not a straightforward discovery. Instead, it's a collection of intriguing clues, each one highly consistent with what we might expect from a biological origin, but not yet definitive proof. These findings spark intense debate and further investigation, as every new piece of data could bring us closer to confirming life on Mars. However, nature is full of surprises. Geological processes, like mineral growth or chemical reactions, can sometimes create features that look remarkably similar to those made by living things. This is why scientists approach every potential biosignature with a healthy dose of skepticism and caution, carefully comparing natural processes on Earth and Mars to avoid being misled by false positives. To help sort through the evidence, NASA uses the confidence of life detection, or COLD scale. This tool ranks discoveries based on how likely they are to be true signs of life. For example, the recent findings in Sapphire Canyon are considered compelling and sit right in the middle of the scale, suggestive, but not yet confirmed. This system helps scientists communicate the level of certainty and guides future research priorities. The minerals and textures found in these Martian rocks are difficult to explain without invoking life. Their shapes, arrangements, and chemical compositions closely resemble those produced by microbes on Earth, yet scientists must also consider whether rare, non-biological processes could have created them, especially in the unique environment of Mars. One important clue is the lack of evidence for extreme conditions, like high temperatures or acidity, which are often needed for non-biological processes to mimic life. The relatively mild environment strengthens the case for a biological explanation, making the findings even more intriguing. Each new discovery helps narrow down the possibilities. As more data is collected and alternative explanations are ruled out, the idea of a biological origin becomes a stronger contender. But the process is slow and methodical, requiring careful analysis and repeated testing. In the end, scientific rigor demands patience and thoroughness. Every alternative explanation must be tested and eliminated before we can confidently claim to have found life beyond Earth. The search continues, driven by curiosity, caution, and the hope of a groundbreaking discovery. NASA leaders call this the closest we've come to discovering ancient life on Mars. Nikki Fox and Sean Duffy both describe the find as groundbreaking, marking a turning point in planetary exploration. Lead scientist Joel Hurowitz notes the mineral patterns match what microbes leave behind on Earth. Yet, he stresses the need for further investigation and skepticism. The team's message: this is a historic leap, but confirmation requires more evidence. Their blend of excitement and caution sets the tone for the next phase of discovery. This discovery's impact goes far beyond science. It's a moment that will ripple through every aspect of our society, from the way we view ourselves to the way nations interact on the world stage. The boundaries between scientific achievement and political ambition are blurring, as leaders and experts alike grapple with the implications of what's been found. In classrooms and laboratories around the globe, young minds are being ignited with curiosity. This breakthrough will spark new funding and global interest in astrobiology, inspiring a new generation of explorers, scientists, and engineers. Students who once dreamed of reaching the stars may now see a real path forward, motivated by the possibility of uncovering life beyond Earth. The Mars sample return mission, once under threat due to budget constraints and political debate, now has a powerful justification, retrieving possible evidence of alien life. This mission is no longer just a scientific endeavor. It's become a symbol of human determination and international cooperation, with the potential to answer one of humanity's oldest questions: are we alone? The find could drive innovation in robotics and AI, pushing engineers to develop smarter, more autonomous machines capable of exploring harsh, distant worlds. As nations race to develop the best technology, we may see a new era of breakthroughs that benefit not just space exploration, but life here on Earth as well. The competition could be fierce, but so too could the opportunities for collaboration. If life is confirmed, it would unite humanity in awe and wonder, while also challenging our philosophical and ethical beliefs. Debates will erupt about how to protect Martian life, what rights it might have, and how our discoveries should shape future exploration. The conversation will extend far beyond scientists, touching philosophers, ethicists, and everyday people. Other nations will accelerate their Mars efforts, eager to contribute to this new chapter in human history. We'll see increased collaboration between space agencies, as well as healthy competition, driving innovation and progress. The race to Mars is no longer just about national pride, it's about the shared pursuit of knowledge and the future of humanity. The stakes are higher than ever. Mars is now the stage for humanity's greatest scientific quest. Every mission, every discovery, will be watched by billions, as the world holds its breath for answers that could redefine our place in the cosmos. The Sapphire Canyon sample has transformed Mars from a distant curiosity into a global priority. What was once the realm of science fiction is now the focus of international policy, investment, and imagination. The world is watching as history unfolds, united in anticipation and hope for what comes next. The journey has only just begun. Perseverance's instruments are powerful, but only Earth labs can provide definitive answers. The Mars sample return mission is now essential. Bringing Sapphire Canyon home is the next step. The plan: a new lander, a fetch rover, a rocket launch from Mars, and a return to Earth. Once here, scientists will use advanced tools to search for fossilized microbes and chemical signatures of life. Only this level of scrutiny can rule out non-biological origins. The mission faces budget and technical challenges, but the pressure to succeed is immense. Sapphire Canyon is now the crown jewel among 27 collected samples. The world awaits as NASA and its partners race to bring this piece of Mars home. Perseverance's discovery is a testament to human curiosity and the drive to explore. It's the result of decades of work by thousands across the globe, united by a quest for knowledge. Supporting science is an investment in our future and our identity as explorers. Whether or not Sapphire Canyon contains proof of life, the pursuit itself is a victory. The search will teach us about planets, life, and ourselves, inspiring new generations. Missions like this remind us what we can achieve together. As we await the next chapter, let's champion discovery and keep reaching for the unknown. The journey continues. Keep looking up, keep exploring, and keep asking questions.